Right now, sitting quietly on the calendar, exactly 4 weeks away, is a date that astronomers have been counting down to for months. On the night of August 28th into the early hours of August 29th, 2026, the moon is going to slide almost entirely into Earth's shadow and turn a deep, coppery red in the sky. Not a small dim patch, not a subtle, darkening only a telescope could catch. 96% of the entire lunar disk swallowed by darkness, glowing red-orange, visible with nothing more than your own two eyes. This is not a total eclipse, but here's the detail that should actually catch your attention. It is going to look almost exactly like one, and astronomers are already calling it the best lunar eclipse anywhere on planet Earth until New Year's Eve of 2028. Nearly 1 billion people are going to witness at least part of it happen live in their own night sky. No equipment required, no risk to your eyes, nothing standing between you and one of the most striking sights the solar system has to offer. Stay with me, because by the end of this, you're going to know exactly when to look up, exactly where to be standing, and exactly why this particular eclipse is such a rare, narrow miss. I am your name, and this is your channel. Subscribe now if you want more stories like this, because we are just getting started. Let's start with the basic mechanics of what is actually about to happen, because understanding this makes the whole event genuinely more incredible to watch, rather than just a red smudge in the sky you don't fully understand. A lunar eclipse happens when Earth positions itself directly between the sun and a full moon. The moon passes through the shadow that Earth casts out into space. That shadow actually has two distinct parts. The outer part is called the penumbra, a zone of partial shadow where sunlight is only partially blocked. It causes a faint, subtle dimming that most casual observers barely notice at all. The inner part is called the umbra, the true dark core of Earth's shadow, the region where sunlight is almost completely blocked. When the moon passes fully into the umbra, you get a total lunar eclipse, and the entire lunar disk turns that famous deep red color people call a blood moon. When the moon only partially crosses into the umbra, you get a partial eclipse, where a portion of the moon goes dark and red, while the rest remains bright and silvery white. What is happening on August 28th and 29th is technically, by the strictest definition, a partial eclipse. The moon is not going to fully immerse itself inside Earth's umbra. But here is why that technicality barely matters for anyone actually standing outside looking up. At the moment of maximum eclipse, 96.2% of the moon's entire disk will be covered by that dark inner shadow. Only a thin, narrow sliver of the lunar surface, roughly 4%, will remain outside the umbra, still catching direct sunlight. Picture the moon as a clock face with almost the entire dial swallowed by shadow, except for one small bright edge glowing along the rim like the last unburned strip of a photograph curling in flame. Astronomers are describing the overall look of the event as remarkably similar to a full total eclipse, with most of the lunar surface expected to take on that same deep coppery reddish-orange hue, and only that narrow silver lining left bright and untouched. Now, the part everyone actually wants to know, when and where. The eclipse unfolds over several hours, but the moment of maximum eclipse, the peak of the entire event, when that 96.2% coverage is reached, happens at 4:12 in the morning, Greenwich Mean Time on August 28th. If you're watching from the eastern United States, that translates to 12:12 in the morning Eastern Daylight Time, technically already into the very early hours of Friday, August 28th, even though for most of the country this reads as a Thursday night event. On the West Coast, that same peak moment lands at 9:12 in the evening, Pacific Daylight Time on Thursday, August 27th, meaning viewers there catch the peak, while it's still comfortably evening. In the Central Time Zone, that's 11:12 p.m. Thursday night. In the Mountain Zone, 10:12 p.m. The full eclipse, from the very first faint touch of shadow to the moment it completely clears the moon's surface, lasts 5 hours and 38 minutes in total. But the part actually worth setting an alarm for, the deep, dramatic partials. Phase where Earth's shadow is visibly eating into the lunar disk, and the reddish coloring becomes obvious, lasts about 3 hours and 18 minutes, running from roughly 2:33 to 5:52 in the morning Greenwich time. You do not need to watch the entire 5.5-hour event to get the full experience. The dramatic window, the part where the sky show actually happens, is that 3-hour stretch centered on the peak. Geographically, this is about as generous an eclipse as the sky offers. It will be visible across North America, South America, Europe, and Africa, putting a huge fraction of the world's population somewhere within viewing range. According to Time and Date's eclipse tracking, roughly 987 million people, close to 1 billion, will be positioned to see the entire event unfold from start to finish, both the subtle penumbral dimming and the dramatic partial phase. A further 1.3 billion people, roughly 16% of everyone on the planet, will catch at least the full deep partial phase, even if they miss some of the fainter opening or closing stages. Add those numbers together, and you're looking at well over 2 billion people around the world with some kind of view of this event, weather permitting. The best seats in the house belong to North and South America. Across most of North America, including large parts of Central America, South America, and even Greenland and Antarctica, observers will get to watch the entire eclipse from beginning to end, high in a properly dark night sky. Europe and Africa are positioned differently. For those regions, the eclipse happens much closer to moonset, meaning observers there will be watching the event low on the horizon just before the moon sets and the sun comes up, rather than watching it arc overhead in full darkness. And if you're in Asia, or the surrounding region, unfortunately this one mostly isn't for you. The moon will simply be below the horizon during the entire event, meaning it won't be visible there at all. There's one more geographic quirk worth knowing if you're on the west coast of North America or somewhere out in the Pacific. In those locations, the moon will actually rise, while the eclipse is already partway through happening. You'll miss the opening act. The first faint bite Earth's shadow takes out of the lunar disk, but you'll still get to watch the moon come up over the horizon already partially darkened, which by most accounts is its own kind of striking, almost eerie sight. A moon that rises already wounded, so to speak, climbing into the sky mid-transformation rather than starting whole. As for where on the planet actually has the best odds of clear skies to see any of this at all, that comes down to plain weather statistics rather than astronomy. Based on historical cloud cover patterns for late August, the best odds currently favor the western United States, northern Chile, and inland Brazil, regions that tend to run drier and clearer at this time of year. That's not a guarantee, obviously. Weather forecasts for a specific night a month out are still just educated guesses. But if you're planning ahead and have any flexibility in where you'll be standing that night, those are the regions with history on their side. Now, here's a question worth answering directly, because it's the first thing most people ask. Do you need a telescope, special glasses, or any equipment at all to watch this? No. And this is one of the genuinely nice things about lunar eclipses compared to their more famous cousin, the solar eclipse. A solar eclipse requires special, certified eclipse glasses because you're looking directly toward the sun, and doing so without protection can permanently damage your eyes. A lunar eclipse involves none of that risk whatsoever. You are looking at the moon, reflected sunlight. At night, the same as any other night you've ever glanced up at a full moon. It is completely safe to watch with the naked eye, start to finish, no equipment required. All you actually need is a clear sky and a spot with a decent view toward wherever the moon happens to be sitting from your location. Let's talk about why the moon turns that deep red color in the first place, because it's one of those facts that sounds almost too strange to be true, and yet it's just straightforward physics. When the moon passes into Earth's shadow, you might expect it to simply go black, disappear into darkness entirely. It doesn't, because Earth has an atmosphere, and that atmosphere does something remarkable to sunlight passing through it. As sunlight grazes past the edges of our planet on its way toward the moon, Earth's atmosphere filters out most of the shorter wavelengths of light, the blues and greens, through a process called Rayleigh scattering, the exact same phenomenon responsible for making our sky blue during the day and our sunsets orange and red. What's left after that filtering is mostly the longer, redder wavelengths of light, and that filtered red light gets bent or refracted by the atmosphere and cast onto the surface of the moon. In effect, you are looking at the combined light of every sunrise and every sunset happening on Earth. At that exact moment, all of it bent around our planet and projected onto the lunar surface, 239,000 miles away. That is genuinely what causes the red color. You are not looking at the moon in darkness. You are looking at the moon lit entirely by the light of Earth's own atmosphere. Let's put this event into context against what's come before it and what's coming after, because that's really what makes astronomers so excited about this particular date. Earlier this year, on March 3rd, 2026, the world witnessed a full total lunar eclipse, the real deal. The moon completely swallowed by Earth's umbra, glowing red for a genuine totality period lasting 58 minutes and 15 seconds. That eclipse was visible across North America, the Pacific, Australia, and New Zealand. And for viewers in North America specifically, it was also the last true total lunar eclipse they'll get to see until 2029. That's the key fact that explains why this upcoming August event matters so much. After March's total eclipse, there is no other true total lunar eclipse visible anywhere on Earth until New Year's Eve, December 31st, 2028. That's a gap of nearly 3 years with no full blood moon anywhere on the planet. This August 27th event, at 96.2% coverage, is the closest thing to a substitute the sky has to offer during that entire gap. And by most practical measures of what it will actually look like to the naked eye, it might as well be one. There's something almost poetic about how close this eclipse comes to being total, without quite crossing that final threshold. The difference between a fully total eclipse and this one comes down to the moon's precise path through Earth's shadow that particular night, a matter of celestial geometry playing out with almost frustrating precision. Slide the moon's path just slightly closer to dead center through Earth's umbra, and this becomes a true total eclipse with the whole disk submerged in red. As it stands, that narrow 4% sliver stays just outside the deepest shadow, catching a thin rim of direct sunlight, while everything else around it goes dark. It's a reminder of just how exact and mechanical these celestial events actually are. We're not talking about approximate timing or rough estimates. Astronomers can tell you, down to the minute, when Earth's shadow will begin touching the lunar surface, and predict that 4% sliver with the same precision people use to predict the tides. If you want a quick reference for exactly when to be outside, here it is again, laid out plainly. Maximum eclipse, the moment of deepest coverage, hits at 4:12 a.m. Greenwich Mean Time on August 28th. That's 12:12 a.m. Eastern Daylight Time, 11:12 p.m. Central Daylight Time the night before, 10:12 p.m. Mountain Daylight Time the night before, and 9:12 p.m. Pacific Daylight Time the night before. The full dramatic partial phase, worth actually watching rather, than just checking in on, runs from roughly 2:33 to 5:52 a.m. Greenwich Time, a 3-hour and 19-minute window centered on that peak moment. Find a clear patch of sky, ideally somewhere without a lot of direct light pollution nearby, though unlike a meteor shower, you don't need true rural darkness to appreciate this one since the moon itself is bright enough to see clearly even from a reasonably lit backyard or rooftop. One more thing worth knowing if you're the kind of person who likes planning ahead. This won't be your last chance at something spectacular in the sky this year, not by a long shot. Just 2 weeks before this lunar eclipse on August 12th, 2026, there's a total solar eclipse crossing parts of the globe, one astronomers have already flagged as offering millions of people a rare and dramatic sunset totality. And looking further out, an annular solar eclipse, the kind that produces the striking ring of fire effect, is already on the books for February 6th, 2027. The sky, it turns out, has a packed calendar this year and next, and this August blood moon is simply the next confirmed date on it. So mark it down. August 27th into the 28th, 2026. No equipment, no risk to your eyes, no cost, just clear skies and a view toward the moon. 96% of the lunar disk swallowed by Earth's shadow, glowing that deep coppery red that comes from every sunrise and sunset on the planet, bending around Earth and landing on a rock 239,000 miles away. The best eclipse anyone on this planet will see until the very last night of 2028. If stories like this, the ones that get you looking up instead of just scrolling past, are what you come here for, subscribe and turn on notifications now, because we've got the August 12th total solar eclipse coming up first, and I'll have everything you need to know about where to be standing and when. Drop a comment and let me know which time zone you're watching from, and share this with someone who needs a reason to set an alarm that night.